Enzymes work as catalysts because they have the ability to bring substrates together. They can hold substrates and they provide acidic, basic, or other types of groups required for catalysis. They lower the energy barrier by inducing a change in the bonds of the substrates. The factors that affect the rate of the catalysis are the concentration of the substrates, the concentration of the enzymes, the pH, and the temperature. If the concentration of the substrate is low relative to the concentration of the enzymes, not all the active sites of the enzymes are occupied by a molecule of the substrate. In this part, the rate increases when the concentration increases. However, when the concentration continues increasing, there is a point where all of the active sites of the enzymes are occupied, reaching what is called the level of saturation. At this point, all of the active sites are bound, forming the ES complex, and there is no chance for the rate of the reaction to increase. Some enzymes are known to have what is called kinetics perfection, and that is that enzymes only are limited by the time needed for the substrate to reach the active site. That means that once the substrate reaches the active site, it transforms into product. The rate cannot be faster than the rate of diffusion control, which means the time needed for the reaction to take place is that needed for the substrate to reach the active site. Vmax is the reaction rate when the enzyme is fully saturated. Km is the substrate concentration at which the reaction rate is half its maximum. The rate of a reaction catalyzed by an enzyme is directly proportional to the concentration of the enzyme. If the concentration of enzyme increases, the rate of the reaction also increases. The catalytic activity of many enzymes depends on the pH at which this enzyme is at. The pH of maximum rate is defined as the optimum pH. Pepsin is an enzyme that acts in the stomach. Its optimum pH is around 2. This means that a pH lower than 2 or higher than 2, the rate of the catalysis decreases. In another hand, trypsin is an enzyme found in the small intestine and its optimum pH is about 8. Small changes in pH will change the ionization state of the amino acids that are lining the active sites that are in charge of forming the ES complex. A great majority of enzymes have their maximum activity between the pH values of 5 and 9. Large changes in pH denature the proteins. The rate of chemical reactions increase by an increase in temperature. That is because of the greater opportunity for collisions between molecules. However, enzyme catalyzed reactions do not increase in rate by a continuous increase in temperature. Most enzymes denature and lose their catalytic activity at temperature above 50 degrees. As we can see, when the temperature increases, the rate of the reaction also is increasing up to a point where the maximum temperature allows. Beyond this point, the rate of the reaction decreases. Most enzymes operate about 37 degrees. Cooling down an enzyme does not denature the tertiary structure of the protein. Extremozymes are enzymes that can survive either high temperature or very low temperatures. Among those we find thermophiles, which are enzymes found in bacteria that inhabit the hot springs in Yellowstone National Park. Those enzymes can survive very high temperatures.